So in this video, I'm going to be showing you how to use the Newton Raphson method to solve for the cube root of 37. But before we do that, I will show you generally how to employ the Newton Raphson method to solve for the cube root of any given variable or function. Now let's say x is equal to the cube root of n, where n is simply a number, and we are to evaluate this using the Newton Raphson method. Okay, so cube root of n. So the first thing to do is to eliminate the cube root. So we have to take the cube of both sides, and if we do that, we are going to have x to the power of 3 is equal to n. Now we need to simply send n to this side of the equation just to achieve our function to be of the form f of x is equal to 0. So if we do that, we're going to have x cubed minus n to be equal to 0. So this simply implies now that our function f of x is now equal to, so you can call this f of xn is now equal to x cubed minus n, and you have this. Now you recall your Newton Raphson's formula. The formula simply states that xn plus 1 equals xn minus f of xn all over f prime of xn, where our f of xn, which is the function, is simply this. So which means we need to find f prime of xn. That is simply differentiating this given function. And if we do that, differentiate x cubed, you will simply have 3x squared. So this is now going to be 3xn. So in place of x, now simply put it as what? Xn. Let us just be generic and work along with the formula. Okay, so if I differentiate n, of course n is a constant, an integer, its derivative becomes 0. So our f prime of xn simply gives us 3x squared n. Now let's plug these values into the given formula. We are going to have that xn plus 1 is going to be equal to, remember, we have xn minus f of xn. F of xn simply is xn cubed minus n. So we have xn cubed minus n divided by f prime of xn. That gives us 3xn squared. So you have 3xn squared. Now xn plus 1 is going to be equal to, simply take LCM. 3xn squared multiplies xn. That gives us 3xn cubed. Okay, minus multiplies xn cubed here gives us negative xn cubed, minus times minus n here gives us plus n all over 3xn squared. Okay, so this is going to be equal to 3xn cubed minus xn cubed. This simply gives us this gives us 2xn cubed plus n all over 3xn squared, and you have this. So you can split that relationship, and you're going to have xn plus 1 to be equal to, this simply gives us 2xn squared, 2xn cubed all over 3xn squared, okay, plus n all over 3xn squared. And this is going to be equal to, over here, xn cubed cancels xn squared. So I'll simply have 2xn all over 3, okay, plus n all over 3xn squared. Now, if you compare these two equations, you observe that 1 over 3 is common between the two of them. So you're simply going to have xn plus 1 to be equal to 1 all over 3 is common into, you have 2xn, okay, plus n all over xn squared. So this is the formula you use to solve the cube root of a given function using the Newton Raphson method, and we're going to be employing this formula to solve the cube root of 37. So let's say x is equal to the cube root of 37. So we want to use the Newton Raphson method now to solve for the root of this given equation. Remember, the first thing to do is take the cube of both sides, and if you do that, you're going to have that x cubed is equal to 37. Now send 37 over to this side of the equation. you simply have x cubed minus 37 to be equal to 0. So this implies now that our function f of x is equal to x cubed minus 37. Now, the first thing to do in this case is to find your initial guess. And I always say initial guess, if it's not given to you, the formula remains x naught equals a plus b all over 2, where a is a value that causes this function to change into positive, and b is a value that causes this function to change directly from positive into negative. Okay, so we're going to be picking out values such that when we plug them into this equation, it will change this equation directly from positive to negative or directly from negative to positive. So let's take a scale of 3. So 0, 3, 9, and so on. Now let's try when x is 0. So we are going to have f of 0. This is going to be equal to 0 cubed minus 37. This remains negative 37, and this value is negative. Let's try when x is 3. We find f of 3. This is going to be what? 3 cubed minus 37, and 3 cubed is 27. 27 minus 37 once again gives us negative 10. The value is also now negative, so you can't pick any of these two, okay, because we are still on negative and negative. It has to change from negative directly into positive. So with 3, we have a negative value still. Now let's try again. Remember, the range we are taking is 3. So let's try again. That means our next value is going to now be what? 6. So we'll try f of 6. This becomes 6 to the power of 3 minus 37. So let's see what this value gives to us. So that gives us simply 179. So we have 179, and this value is positive. So this simply means that A is equal to 6 and B is equal to 3. So B is the value that causes the function to be negative, in this case 3, whereas A is the value that causes the function to be positive, in this case 6. So we can now find our initial guess. X naught is equal to 3 plus 6 all over 2. This simply implies that our initial guess x naught is equal to 3 plus 6 is 9. 9 divided by 2 gives us 4.5. Now, having found the initial guess as 4.5, you simply now plug into the formula. Now, remember, this initial guess is when n is equal to 0, we had x naught. So that means that we can use this to find our first iteration. In that case, n is equal to 0. So here becomes xn plus 1 becomes x0 plus 1, which simply gives us what? X1, which is our first iteration. So the equation becomes 1 all over 3 into 2x naught plus n all over x naught all squared. This becomes now our equation. So this is going to be equal to 1 all over 3 into 2 times x naught, and x naught itself is 4.5. So we have 2 times 4.5, okay, plus we have n all over n remains 37, which is the value of which we're looking for the cube root 37, okay, divide by x naught squared. So we have x naught once again is 4.5. So divide 4.5 all squared. So let's try this and see. Our first root x1 equals 1 all over 3 into, let's evaluate everything inside the bracket. Okay, 2 times 0.5, sorry, 2 times 4.5 is 9, plus, let's now evaluate 37 divides 4.5 squared. So 4.5 squared is 20.25. 37 divides 20.25. That simply gives us approximately 1.8272. 1.8272. So let's add that with 9 and multiply by 1 over 3. So everything here gives us approximately 3.60. So this implies that x1 is equal to 3.6091 approximately. 3.6091. So we have our first root. Now we also employ the same formula to iterate for the second root. So for the second root, this now becomes x2 equal to the same formula, 1 all over 3 into 2. So instead of 2x naught, it becomes now 2x1 because we've already found the value of x1. Okay, plus n all over x1 all squared. So the formula basically remains the same, but we'll simply now keep on plugging in the value of our current iteration, okay, or the value of our previous iteration into the current iteration for the formula. Okay, so this is going to be equal to 1 all over 3 into, we have 2 times x1, which is now 2 times x1 itself is 3.6091, okay, plus you have n divides x1 squared, and n is 37 all over x1 again is 3.6091 all squared. Okay, so let's evaluate this and see. All right, so x2 is going to be equal to 1 all over 3 into, let's find 2 multiplies 0.3, sorry, let's find 2 multiplies 3.6091. That gives us 7.2182, okay, plus, let's now find 3.6091 squared. 37 divides 3.6091 squared, please. That gives us approximately 2.8406. Okay. So let's find that sum multiplied by 1 all over 3. So this simply implies that x2 is equal to 3.3529 approximately. Okay, so we've gotten our second root. Now, the second root, of course, does not converge with the first root. So we continue to what? We continue to iterate until convergence occur. So we find the third root. Same thing. Now, in the third root, second root now replaces all the parameters or all the variables in the formula. So you're going to have 1 all over 3 into 2x2 plus n all over x2 all squared. So this is going to be equal to 1 all over 3 into 2 times our x2 there is 3.3529. So 3.3529 plus n remains the value of which we are looking for the cube root, which is 37 all over, once again, 3.3529 all squared. Okay, so let's evaluate the bracket. X3 is equal to 1 all over 3 into, let's find 2 multiplies 3.3529. That gives us 6.7058. Okay, 6.7058 plus, let's find 37 divides 3.3529 squared. That gives us approximately 3.2912. Okay, so let's sum this and multiply by 1 all over 3. So this simply implies that x3 is approximately, we have 3.3323. Okay, so we'll have our third root to be 3.3323. If you compare this with the previous root, it only converged to one decimal place, 3.3, 3.3. But at least, like I said in all my iteration videos, always target at least 2 decimal places before you can stop your iteration. And if you have a way, try to see if you can have up to the 4 values converging. Okay, so we still continue to what? Iterate. All right. So we try now the fourth iteration. Remember, the formula becomes x4 equals 1 all over 3 into 2 multiplied by x3 plus n all over x3 squared. So this is going to be equal to 1 all over 3 into 2 times x3 is 3.3323. So 3 times 3.3323 plus 37 all over 3.3323 all squared. So let's find the bracket. Let's evaluate the bracket. X4 is going to be 1 all over 3 into, let's now find 2 multiplies 3.3323. That gives us 6.6646 plus, let's find 37 divides 3.3323 squared. That gives us approximately 3.3321. Okay, so this simply implies that x4 is going to be equal to, so let's add this up and multiply by 1 over 3. So this simply gives us 3.3322 to approximately. So you see that correct to 3 decimal place, this root has converged. Correct to 2 decimal place, 3 decimal place, sorry. So I have 3.332. I'm also having 3.332. So you can choose to stop your iteration here and assume that that is your answer. But let's try one more iteration and see if it is going to converge correct to 4 decimal place. Else we can stop it in 3. But let's try one more iteration. So we'll try the 5th root. Okay, we'll try to obtain the 5th iteration. So the formula now becomes x5 equals, remember, is going to be 1 all over 3 into 2x5, 2x4, sorry, 2x4 plus n all over x4 all squared. So this is 1 all over 3 into 2 times x4 remains 3.3322 plus 37 all over 3.3322 all squared. Okay, so let's evaluate what's in the bracket. X4 equals 1 all over 3 into, let's find 2 multiplies 3.3322. That gives us 6.6644 plus, let's find 37 divides 3.3322 squared. That gives us approximately 3.3323. Okay, so let's evaluate this and find x5. Let's add up with 6.6644 and then multiply by 1 over 3. So we have x5 to be 3.3322. So once again, you now confirm that correct to 4 decimal place, the root has converged, and the answer is simply 3.3322. So if you go to your calculator and punch the cube root of 37, I can assure you that you're going to have 3.3322. But this is how to employ the Newton Raphson method to solve for the cube root of a given function. I hope you find this video very interesting and helpful. Please, if you do, I would like you to leave a like and comment nicely on the comment section, and of course share to your friends, and of course click the subscribe button and turn on your notification bell so you don't miss out on our subsequent videos when it drops. I will see you in the next video. Cheers.